We're now going to discuss the derivatives of logarithmic functions. Let's review log functions first. Remember that logarithmic functions are a fancy name for the inverse of exponential functions. For example, if we have the function y equals e to the x, then the inverse of this is y equals ln of x, called the natural logarithm. Y equals natural log of x if and only if x is equal to e to the y for x greater than 0. For example, since e to the 0 equals 1, this means that the natural log of 1 equals 0. We simply flip the x and the y values. Notice that the natural log function is only defined for positive numbers. In other words, its domain is x greater than 0. Now that we've reviewed, we're going to discuss the derivative of log functions. The great thing about the derivative of log functions is that while log functions themselves can be a little intimidating and ugly to compute, their derivatives are quite beautiful. We're going to find them using implicit differentiation. If y equals natural log of x and we want to find dy dx, we can rearrange this to be e to the y equals x, then use implicit differentiation. Since the derivative of e to the whatever is e to the whatever, we get e to the y times dy dx on the left-hand side. On the right-hand side, we just get 1. So e to the y times dy dx is equal to 1. Solving for dy dx, we get that this is equal to 1 over e to the y. We know what e to the y is. It's x. So dy dx is equal to 1 over x. In other words, the derivative of natural log of x is 1 over x. Said more casually, the derivative of natural log of something is 1 over that something. Keep this in mind as we do more complicated examples. More generally, if you want to take the derivative of the log base a of x, this is 1 over natural log of a times x. Let's do some examples. Let's find y prime of y equals natural log of x squared. Now that we know the derivative rule for this, we can just use a chain rule. The outside function is the natural log, and the inside is x squared. So we get for the derivative 1 over the inside, which is x squared, times the derivative of x squared, which is 2x. When we simplify, we get 2 over x. This may look strange. Isn't this just basically 2 times the derivative of natural log of x? It is. Let's remember our log rules. ln of x squared can also be written as 2 times natural log of x by bringing down the power. So now when we take the derivative, we just drag along the 2 and take the derivative of a natural log of x, which is 1 over x, leading to the same answer of 2 over x. Let's quickly review all of our log rules. If we have the natural log of a raised to the b, we can bring down the power to get b times the natural log of a. Natural log of a times b is equal to natural log of a plus natural log of b, and similarly, natural log of a over b is equal to natural log of a minus natural log of b. And if we have another log base, we can move to the natural log by doing natural log of b divided by natural log of a. If you've lived in the north, you can remember this rule by the following. The base goes into the basement of the expression on the right. We will use these facts to take the derivative of more complicated functions.